Density. So density is the ratio of the mass of a substance to its volume. It is a fundamental property of a substance. If you have a piece of iron and you cut it in half, or you make a really big piece of iron, the density is the same. It doesn't matter how big the thing is, because if you get a larger piece, the mass increases, but so does the volume. The ratio stays the same for a given substance. So this is an equation you need to know. Density equals mass divided by volume. We calculate the density just by taking the mass of whatever they give us and dividing by the volume. So the example here, a sample of liquid has a volume of 22.5 milliliters and a mass of 27.2 grams. Calculate the density. So this uses an equation. The density equals the mass divided by the volume. So make sure you identify these correctly. The mass is 27.2 grams. The volume is 22.5 milliliters. Then you do the math. Don't leave a fraction. So 27.2 divided by 22.5. How many sig figs will that result have? 3. Each of these numbers has 3 sig figs. So as I'm writing this down, just to save myself a little effort, there's the 3 sig figs, and then I'm going to write down 2 extra digits. And the units that are left, nothing happens canceling out units. It's just grams over milliliters. And then when I round this, I'm going to report the answer as 1.21 grams per milliliter. Any questions? It is possible to do problems with density using that equation and rearranging it. If you are good with algebra and can rearrange equations in your sleep, you are welcome to do that. My experience is that people do a lot of crazy things and end up with wrong answers when they do that, so I'm not going to go over how to do that. We're going to use density as a conversion factor. So let's look at this. A customer purchases a platinum ring. Well, this is still calculating density. A customer purchases a platinum ring that has a mass of 9.67 grams and displaces 0.452 cubic centimeters of water. Is the ring genuine? And we're given that the density of platinum is 21.4 grams per cubic centimeter. If the ring is platinum, its density will be very close to 21.4. It might not be exact because the customer measuring the mass and the displacement might be a little bit off, but it should be extremely close. Displacement is a method of finding the volume of an irregularly shaped object. Let's think about this. If you fill up the bathtub to the very tippy top and then get into it, what happens? Your mom gets mad. Water is displaced, right? Why? Your body displaces it. So when we put a solid object into a volume of water, the level of the water rises in correspondence to the volume of the object that is submerged. And we'll be doing that in lab tomorrow. We're not going to worry too much about it now, but that's what that means. So we need to calculate the density of the ring. Density is mass over volume. To calculate a density, you do use the equation. But it doesn't generally cause any problems because you don't have to rearrange it. So we need the mass, 9.67 grams. A lot of times it'll tell you, it says mass of. If it doesn't, we should recognize that gram is a unit of mass. And here displaces this many cubic centimeters. It doesn't use the word volume. If you didn't know what displacement was, because I didn't just explain it to you, or you weren't listening, how could you know that this is the volume? Because this is a unit of volume. A cubic length is a unit of volume. So that's the volume, 0.46, that's not 6, 0.452. So 9.67 divided by 0.452. How many sig figs? 3. So there's 3. I'm just going to write down 2 more. The units do not cancel out. I just record them as they are. And then I round this, and it's 21.4 grams per cubic centimeter. That's the density. Did I answer the question? No. It didn't ask me to calculate the density. I needed to, but it didn't ask me to. The question is the ring genuine? Yes. So the answer to the question is yes. Any questions? Density can be used to identify a substance. Density is a great conversion factor. So if we have a liquid substance that has a density of 1.32 grams per cubic centimeter, and we want to know what volume we should measure out so that we get a mass of 68.4 grams, we can use dimensional analysis and solve this problem. So you read through the question, you pull out the numbers, and you write them down. So we've got 1.32. This fraction is written with a slash so that it's all on one line because it's a lot easier to do in the computer. When you're writing this out by hand, it doesn't matter in terms of difficulty whether you make it a vertical fraction or horizontal. Always make it a vertical fraction. So this is grams divided by cubic centimeters. And the other number is 68.4 grams. So we've got 2 numbers. We may not be sure which one we're supposed to start with. That's okay, we wrote them down. Then, what is the question? What volume? It doesn't specify a unit. What would be the most convenient unit? One that's already showing up in the problem. So cubic centimeters is a volume unit, and that's already in there. So we're trying to find cubic centimeters. Now, when we look at these 2 numbers to identify which one should we start our conversion with, this is per units, grams per cubic centimeters. That's the conversion factor. This is just grams. That's where we start. So we're going to have grams, and we're going to go to cubic centimeters. So 68.4 grams. I have 1 arrow. I have 1 fraction. Cubic centimeters goes on the top. Grams goes on the bottom. The grams cancel out. The units are looking good. Units first. The relationship between cubic centimeters and grams is the density, and it is specific to this problem. It's 1.32 grams per cubic centimeter. So 1.32 needs to stay with gram. So it's going to go in the bottom. And if I need a number on top, it's going to be a 1. I don't have to think about, do I multiply or divide by the density? I don't need to rearrange an equation with fractions. I just put the units in and they tell me where to put the number. Please do your densities this way, okay, on the worksheet. Practice it. Once you see it, it's so much easier than the other way. So 68.4 divided by 1.32. How many sig figs? 3. So 1.8, that's the third one. And then write down 2 extra digits. What's the unit? Centimeters cubed. And then when I round that, 51.8 cubic centimeters. That's the volume I need. Any questions? Yes?
Sorry, what did you mean by you just put in the units? I think I missed something.
So dimensional analysis, we look at the units first. And so we decided we can go grams to cubic centimeters. And I've got grams, times, and a fraction. Cubic centimeters goes on top. Grams goes in the denominator. That's putting the units in first, getting the units to work out. Then the units tell me where to put the numbers.
Oh, so put the units before you put the numbers.
Yeah, put the units in first, and then then that tells me that the 1.32 is going to go in the denominator. It's less thinking. I mean, it's important to think, but it can be tiring, right? And so if you can find a method where you don't have to think as much, I think that's a good method. Any other questions? Here's a table from your textbook, densities of some common substances. You do not need to memorize these. The only one that you should maybe remember is that water has a density of 1 gram per cubic centimeter. But densities would be given to you. Do not memorize them. Okay. On homework problems, on the worksheets, you might have to go look up a density. On an exam problem, I'll give you the density. Okay. A drop of acetone, nail polish remover, has a mass of 35 milligrams and a density of 0.788 grams per cubic centimeter. What is its volume in cubic centimeters? Well, let's write down the numbers. I've got 35 milligrams, and I've got 0.788. Write this fraction vertically, grams over cubic centimeters. We need to clearly see that this is a fraction. We have units on top, we have units on bottom. When you do your calculation, there should be no slashes. Everything should be vertical. What's the question? What's the volume in cubic centimeters? So I need to get to cubic centimeters. I have two numbers, so I have to decide which one to start with. You can't just pick one and start there. One is the correct thing to start with, and the other is a conversion factor. If it's a grams per cubic centimeter, that's the conversion factor. Almost always, like 99% of the time in this class. This is where I'm starting. So I'm starting with milligrams, and I need to get to cubic centimeters. Do I have a relationship directly between milligrams and cubic centimeters? No. I've got the density, but the density is grams per cubic centimeters. Could I convert milligrams to grams? Yeah, because I know what milli means. And then this density will let me go between grams and cubic centimeters. So this one I needed a stepping stone in the middle there. I have 2 steps. Sometimes students want to just make it into one step, and so they do all these side calculations and stuff. You're probably going to get the answer wrong if you do that. Just take the extra step and get to the correct conclusion. So I have 2 arrows. So I have 35 milligrams times in a line, times in a line. My unit path is milligrams to grams to cubic centimeters. So that's what I write here. I've got milligrams to grams to cubic centimeters. Are you seeing the path, the pattern there? Once you've got the path down, that's the hard part. Everything else just kind of falls into place. I want this milligram to disappear, so I put that in the denominator. So milligrams are going to cancel out. And I want gram to cancel out, so I put it in the denominator over there. All the units are in place. Now I need to put some numbers in there. These conversion factors, what's on the top of the line has to be equal to what's in the bottom. So here I have grams and milligrams. I have just one prefix, and then the other is the unit without the prefix. So I've got the prefix milli down here. I write on the top what milli means. Milli means 10 to the minus 3. So 1 milligram is 1 times 10 to the minus 3 grams. Works every time.
Can you just write 10 to the minus 3 instead of writing?
You can, yes, you can write 10 to the minus 3. The reason I started doing 1 times 10 to the minus 3 is because sometimes when students see 10 to the minus 3, they're not sure how to put that into their calculator. And then then it becomes a calculator issue, and we want to avoid that. And then here, this comes from the density. Again, pay attention, what unit is the number with? It's with gram. It needs to stay with gram. So 0.788 grams. And if it bothers you that there's no number up there, you put a 1 in there. So I've got 35 times 1 EE negative 3 divided by 0.788. And this one is going to have how many sig figs? 2. 35 milligrams. It's a whole number, but it's not exact. So 2 sig figs. So I'm going to get 0.0. Those zeros are not sig figs. 4, 4. There's my 2 sig figs. And then write down 2 more digits. Unit is cubic centimeters. So then when I round it, I get 0.044 cubic centimeters. Any questions? Pure gold metal bar displaces 0.82 liters of water. What is its mass in kilograms? Density of gold is 19.3 grams per cubic centimeter. I'm doing several different examples here, and they're all variations on a theme. So write down the numbers. 0.82 liters, and I've got 19.3 grams per cubic centimeter. What are they asking for? Mass in kilograms. So I have to figure out how to get from liters to kilograms. Neither of those units is in my density. But I have grams. Can I convert grams and kilograms? Yeah. All I need to know is what kilo means. So if I had gram, I can work from the back here and say, well, I need to get to grams. Liters, we just don't see much matching up here. It's okay. Keep working from the end. So grams, the density, if I had cubic centimeters, I could use this to get to grams. And now I need to do this. Ugh. Okay, here's an often overlooked conversion factor. 1 cubic centimeter is the same as 1 milliliter. Cubic centimeter is a different name for milliliter. In medicine, they call it a cc for cubic centimeter. It's a milliliter.
Will you give us that for test question?
Probably not. So, if I went liters to milliliters, then I could get to cubic centimeters. People forget this one, and then they're like, there's this gap. There's a hole in the bridge. I can't get across the river. This is the plank you need to get across. So this is like, 4 arrows. It's okay. Let's just write them out. So 0.82 liters, 4 arrows, 4 fractions. There are shortcuts that can be taken. Don't start taking shortcuts until you're really good at this. Okay? So liters to milliliters, to cubic centimeters, to grams, to kilograms. You've got it written down. All you have to do is copy it now. So there's milliliters, and cubic centimeters, and grams, and kilograms. Those are the units in my path. Then I take this liter and I divide by it, so that the liter cancels out. And milliliter goes down here, and it cancels out. And cubic centimeter cancels out. And gram cancels out. Then we need to put numbers in. Well, let's use this one. Grams and cubic centimeters. We'll find the term that has grams and cubic centimeters. And we're going to put 19.3 next to gram. And put a 1 in front of the centimeter. This first term, milliliters and liters. Well, milli means 10 to the minus 3. So I already have milli on top, so I'm going to put what it means on the bottom. 1 milliliter is 1 times 10 to the minus third liters. Over here at the end, I have a similar thing where I've got kilo. Kilos on the top, I need to put the number on the bottom. Sometimes it's the other way around. But the 10 to the something goes on the other side. It never goes with the prefix. So kilo is 10 to the plus 3. And so 1 kilogram is 1 times 10 to the third grams. Yes, that's the same as 1 kilogram equals 1,000 grams. But I'm going to stick with the 10 to the somethings. As you put this into your calculator, just go left to right, multiply by the top, divide by the bottom. You don't need to write anything down in the middle. So 0.82 times 1 divided by 1 EE minus 3. Ooh, I forgot the middle one. I don't have any numbers here. What do I put here? 1 and 1. Times 1 divided by 1 times 19.3 divided by 1 EE3. So this is giving me 15.826 kilograms.
So when you make a conversion, you always want to put EE?
When you enter a number like this, 1 times 10 to the third, you're going to enter that on your calculator as 1 EE and then the exponent. Yeah, you don't put times 10. EE stands for times 10 to the. Make sure that you understand how your calculator works.
When you do all the multiplication on the top and then the division, it gives you like 15826.
Don't do that.
Why?
I can show you why
Later.
later. But if you just take each of them as they come, times the top, divide by the bottom, times the top, divide by the bottom, times the top, divide by the bottom. It's the simplest and most straightforward way. You had a question?
It was
That, okay. See, that often happens. One person has a question, and other people have the same one.
Is it wrong if we put like 1,000 milliliters over 1 liter?
It is not wrong. So this can be written in different ways. 1,000 milliliters is a liter. The problem is that many students don't understand the size difference, and so they'll say 1 milliliter is 1,000 liters, which is like saying an inch is 12 feet. An inch is 12 feet, right? You get the number in the wrong place. So if you're good with that, do that on your own paper, absolutely fine. But I'm talking to most of the students who are just like, right? You feel like that? Oh my goodness, my brain's going to explode. It's only the second day. Just do it this way. Any other questions? Don't want to do that one. End. So we forgot to finish this problem. We got it wrapped up in questions. 2 sig figs in the starting number. Exact. This has 3 sig figs. Exact. And so our answer should have 2 sig figs. The 1, the 5, and that rounds up. And the best answer is 16 kilograms.